Imagine this, a spacecraft powered by resources mined on Mars. No heavy fuel shipments from Earth, no exorbitant costs of interplanetary logistics, just sleek, efficient rockets fueled by the red planet's own supply. It sounds like the ultimate solution for long-term colonization, right? But as with many futuristic ideas, there's a catch, one hidden beneath the dusty Martian soil itself. Enter perchlorates, chemical compounds rich in oxygen and often found in Martian regolith. For scientists and engineers, perchlorates gleam with promise. They're a potential game changer for creating rocket fuel directly on Mars. In theory, perchlorates could be processed into oxidizers that allow spacecraft engines to ignite and burn. But here's the unsettling reality. Perchlorates are as dangerous as they are promising. On Earth, perchlorates primarily show up as industrial contaminants, and they're known for their toxic effects on human health. They disrupt thyroid function by interfering with iodine uptake, which can wreak havoc on metabolism. Now imagine trying to deal with that while surviving on a freezing desert planet millions of miles from Earth. On Mars, perchlorates don't just exist, they dominate. For a Martian colony, this presents a twofold challenge. First, there's the issue of exposure. Any crew aiming to extract perchlorates for fuel production would face the risk of inhaling or absorbing these toxic compounds. Protective measures like advanced filtration systems and sealed environments would need to be flawless to prevent health issues. Second, there's the problem of handling. Perchlorates are notorious for being chemically unstable, which means their incredible potential as rocket fuel oxidizers comes hand in hand with explosion risks. Processing perchlorates safely would require cutting-edge technologies. Think robotics or automated systems designed to minimize human contact. A simple misstep in the extraction or refinement process could lead to catastrophic failure. Of course, none of this is to say perchlorates are insurmountable. Scientists have already speculated ways to neutralize the dangers, like heating Martian soil to release perchlorates and filter them into usable forms, or using bacteria engineered to break them down safely. The problem is, all these solutions require resources, energy, and time that might be hard to come by for a fledgling colony. But here's the big question. Is the risk worth it? Could perchlorates become the key to a thriving Martian presence, despite their dangers? One thing is certain. If this technology succeeds, it could lay the foundation for interplanetary independence. And if it fails, well, humanity might learn the hard way that not all resources are as useful as they seem.